So now let us try to understand all the 6 possible graphs of a quadratic function y is equal to ax square plus bx plus c. Now as we have already derived, this function will be exactly same as this function. X plus b by 2a whole square is equal to 1 by a times y plus d by 4a. This is just a vertical parabola with the vertex shifted to minus b by 2 and minus d by 4. Now, there are 6 different cases of graphs which can be divided into 2 sets. The first set and the second set. And the division is according to the leading coefficient. So as you can see, x square is equal to 4ay. This is of the form x square is equal to 4ay with axis obviously shifted and the vertex obviously shifted. But we know that if this number is positive, then it represents an upward parabola. If this number is negative, it represents a downward parabola. Right? So you have something square is equal to something times y. X square is equal to something times y. This something is 1 by a here. Now whether the graph is upward or downward depends on the sign of 1 by a. So if a is greater than 0, so you get an upward parabola because this is positive. If a is less than 0, you get a downward parabola, the parabola which faces downward. Okay, so the first 3 graphs correspond to a greater than 0, so this represents upward parabola, and a less than 0 represents downward parabola. So whenever you're given a quadratic function, the first thing that you need to observe is what the sign of this a is. If the leading coefficient is positive, you get an upward parabola. If the leading coefficient is negative, you get a downward parabola. The next thing to observe is whether the graph cuts x-axis at 2 points, whether the graph touches x-axis, or whether the graph just does not cut x-axis. So how do we decide which case the graph falls in? That comes from the vertex. The vertex is minus d by 4a. For example, let us take a greater than 0. So if a is greater than 0, and if the graph cuts x-axis, so there can be 3 possible graphs. If the graph cuts x-axis, the graph might touch x-axis and go. The graph might lie completely above x-axis. So as you can very clearly see, if this is the case, then the y-coordinate of the vertex have to be negative. The y-coordinate of the vertex have to be negative. The y-coordinate of the vertex has to be equal to 0. The y-coordinate of the vertex has to be positive. Now the vertex's y-coordinate is nothing but minus d by 4a. We have assumed that a is positive. So the sign of the vertex depends only on the sign of the discriminant. So here I want the y-coordinate of the vertex to be negative. So minus d has to be less than 0. That means discriminant has to be greater than 0. So if discriminant is greater than 0, it has 2 real roots. So it cuts x-axis at 2 points. That is one way. Or the y-coordinate of discriminant is negative. So the graph starts from below x-axis and it goes above x-axis. Hence it has to cut at 2 points. So here the y-coordinate is exactly equal to 0. Hence d is equal to 0. And here d minus d should be positive, so d should be less than 0. So this is how you differentiate between these 3 cases. So correspond to a greater than 0. Correspond to a greater than 0. If d is greater than 0, it cuts x-axis at 2 points. If d is equal to 0, it just touches x-axis and goes up. If d is less than 0, the graph does not cut x-axis. Similarly, so let us go for the next case. So if a is less than 0, that is this number is less than 0, that is negative, hence this represents a downward parabola. Again, in downward parabola also you have three cases. So the graph can be like this. The graph can touch x-axis and come down. The graph can lie completely below x-axis. So when will these happen? So here this happens if the vertex is, the y coordinate of vertex is positive. So minus d by 4a has to be positive. Minus d by 4a has to be greater than 0. So a is already less than 0. A is less than 0. So a is in negative quantity. So negative and negative quantity gets cancelled. Hence d has to be positive. So if d is greater than 0, the graph will look like this. If d is equal to 0, the graph looks like this. If d is less than 0, the graph looks like this. So again, if a is less than 0, the graph is a downward parabola. So with a less than 0, if discriminant is positive, that means the equation has two real roots and the graph has to cut x-axis at two different points. Hence, a less than 0, d greater than 0 represents this graph. A less than 0, d equal to 0. If d equal to 0, that means you have repeated roots. You have only one root, repeating two times. Hence, the graph will touch x-axis. If d is less than 0, that means the graph, the equation does not have real roots. That means the graph should not cut x-axis. So these are the 6 possible cases that you can have with respect to the graphs of the quadratic equations or graphs of quadratic functions. So now let us go forward and see whether you can see some interesting points about these graphs or not.